Welcome to 30 Things You Need to Know About Water. Water, as you should know, is one of the most vital substances for living things. Our bodies themselves are a majority water, and there is something very specific about the structure of water that makes it have a lot of very special characteristics that other liquids or even gases don't have. So, and the biggest thing is that water is what we call a polar molecule. So, polar means that there is a slight imbalance in charges. Okay? So, water itself is a neutral molecule, but oxygen, you can see oxygen is much bigger than the two hydrogens. So we have one oxygen, two hydrogens, that makes H2O, the chemical composition of water. Well, oxygen is bigger, and it's also something called more electronegative. Not necessarily that you need to know that word, but it's called electronegativity. Basically means that electrons are more attracted to oxygen than they are to hydrogen. Okay, so oxygen and hydrogen are sharing electrons. But because the electrons like oxygen a little bit more than hydrogen, they spend a lot more time over here circling the oxygen atom, and then they might go over here for a second and then they will come back. Okay? So because the electrons are hanging out with the oxygen more than they are with the hydrogens, that means that the side with the oxygen, it has a slightly negative charge because electrons bring a negative charge with them. Now, because the oxygen is slightly negative because the electrons are hanging out over there, that means that each of the hydrogens, the ears and the Mickey Mouse over here, are slightly positive. Okay? So that means, so oxygen being a polar molecule, meaning one side is slightly negative and the other side is slightly positive, that is what causes a whole lot of other things. So that's the basis for all of these characteristics of water that we're going to go through in the rest of the lecture today and the lecture next class. Now, when you have a whole bunch of water molecules together, so you have an oxygen here, slightly negative. If you put another water molecule right next to it, you should know that opposite charges attract. So if opposites attract, this is why with magnets, there's a certain side of the magnet that goes together, and if you flip them over, they'll press each other apart because like charges are going to repel. So if you have a positive next to a positive, they're going to repel each other. They're not going to want to be anywhere near each other. If you have a negative charge here, a water molecule right next to that one is going to orient itself so that the hydrogen side is facing that oxygen side. So you have a negative and a positive, opposite charges attract. Okay, so then you have your molecule here. This side is negative, so you're going to have another positive here, negative, positive. This side is negative, it's going to attract a positive. This side is positive, it's going to attract a negative. Okay, so what they're doing is the water molecules are orienting themselves around each other so that there is a slight attraction among all of those molecules. Okay, so what we call these are hydrogen bonds. So hydrogen bonds, we typically show them as dotted lines. So there's a hydrogen bond here, there's a hydrogen bond here, there's a hydrogen bond here, there's a hydrogen bond here. Okay, so, and they're very weak bonds. They're not even real bonds. There's no moving of electrons. There's no sharing of electrons. It's just this slight attraction between the negative end of one water molecule and the positive ends of the other water molecule. The dissociation of a water molecule does not happen very often. It takes a lot of energy to break a water molecule because water is actually a very stable molecule. It would have to be a very stable molecule because it's basically the basis of life, okay? But every now and then, if something splits a water molecule, a hydrogen will break off. So this hydrogen will actually break off of the water molecule, forming what we call an H plus ion, so a hydrogen ion. But what's going to happen is, because remember I said that oxygen has a stronger hold on the electrons, the electron from this hydrogen is going to stay with this oxygen, okay? So this part right here, this hydrogen and oxygen, has an extra electron, which gives this whole thing a negative charge. And this hydrogen left its electron behind, which gives that particular ion a positive charge. So now we have an H plus and an OH negative. Again, that doesn't happen very often. It's very rare because water itself is a very stable molecule. So because water is very stable, and also specifically because of those hydrogen bonds, there are a few characteristics that water takes on. Now, because all of these water molecules are hydrogen bonded to each other, they have something called cohesion. Co meaning together. So what we have is here, the cohesion is the sticking together of like molecules, meaning molecules that are the same. So water molecules are going to stick to other water molecules because of that attraction between the positive end of one molecule and the negative end of another molecule. Okay? Now, it also has the characteristic of adhesion. So adhesion, like if you've ever seen like adhesive bandages, all that means is it sticks to something. It sticks to something else, not itself. So, if you like spill your water and it goes on a wall, it runs down, but it doesn't it doesn't all splash off the wall. A lot of it sticks to the wall as it runs down, or it sticks to glass. And if it runs down like on a car when you're driving in the rain. So water also has that ability of being able to stick to other things in addition to sticking to other water molecules. Surface tension is related to the fact that water molecules stick together. It's related to this property of cohesion. Okay, so it's a measure of how difficult it is to break the surface of a liquid. What that means, I'm sure someone in your life, if not you, at one point has done a belly flop into a pool or a lake or something like that, and you know that if that happens, it hurts. Well, why does it hurt? It's because water molecules sticking together make it more difficult to break through the surface of a liquid. If you actually Google, there are videos where you can take a paper clip and actually float it across a cup of water or a glass of water, as long as it's flat. Okay? As long as it's flat, the surface tension of the water will actually keep that paper clip afloat. Now, if you turn it on its side, it's going to sink down because metal is more dense than liquid. But the surface tension, the attraction of water molecule to water molecule, means that you need more energy to break through the surface. It's because of those hydrogen bonds. Capillary action is the movement of water in thin hollow tubes due to adhesion. So this is actually how the roots of plants work. Okay, so they're thin hollow tubes, and because the water sticks to the sides of these tubes, it actually causes the water to get taken up through the roots and to the rest of the plant. Some vocabulary here. Hopefully everybody knows what a solution is. A solution is a homogeneous mixture, okay? And I skipped down to number 13 to talk about a solution first, because a solvent and a solute are the things that make up a solution, okay? So a solvent is something that dissolves a solute. So if you're putting sugar in water, or salt in water, or hot chocolate, if you're making like hot chocolate, if it's, in the wintertime, the thing that is doing the dissolving, usually it's the liquid, if we're talking about the difference between a liquid and a solid, that is the solvent. The solute is the substance that is being dissolved. So that would be sugar in water or salt in water. Again, we go back to the hot chocolate. The solvent or the solute is the chocolate packet, so the powdered chocolate that you put in the water. So the water would be the solvent and the chocolate would be the solute. A solution is a homogeneous mixture of solute and solvent, meaning it is evenly spread out, okay? Which means that each part of that liquid or each part of what it is exactly the same as every other part. So you know that if you put the chocolate in water when you're making the hot chocolate, a lot of the powder sinks down to the bottom. How do you make that a homogeneous mixture? You stir it up and make sure that the chocolate is evenly dissolved throughout the entire thing. Otherwise, you start drinking it and it's really weak, it doesn't taste very chocolatey, and then you get big chunks of chocolate down at the bottom, okay? So a solution is only a solution if it is homogeneous, meaning all the parts are even. An aqueous solution is just a solution that has water as the solvent. So if it's water doing the dissolving, then it is an aqueous solution. We call water the solvent of life because it can dissolve so many different things. Because of that polarity that water has, it has a lot of different ways that it can actually split up a solute or split up other substances in order to make a solution. Also, in large part to those due to the polarity of water and those hydrogen bonds, water has a very high specific heat. Okay, so specific heat is the quantity of heat or energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius. So essentially, it's just how much energy does it take to heat something up, okay? If it has a higher specific heat, it's going to take more energy to get that to a higher temperature. What that also means is it's going to take a lot longer to cool down. Okay, so water has a specific heat, has a very high specific heat because it has those hydrogen bonds, which gives it a strong resistance to temperature change. So think if you've ever been on a beach on a summer day, okay? Think about if it's early in the summer. So if you go to a lake, if you go to Charlotte Beach or Hamlin Beach or something like that, and it's early in the summer, the water is still really, really cold. But each day, the sand, like around midday, starts to get really, really hot. That's because it doesn't take a lot of energy to heat sand, but it does take a lot of energy to heat water. Now you go back to that same beach in mid-August, and what happened? The water got a lot warmer because it's been absorbing solar energy all summer long. Now what that means is it's also going to take a longer time for the water to cool down. Okay, so it's not going to get super, super cold and freeze in September, October. It's going to take a lot longer to lose all of that energy. So think about like metal in the summertime. Okay, if you ever touched your seatbelt, if it's been sitting in the sun for a long period of time, it's really hot. But at night, it gets really cold really easily because it doesn't hold on to that energy. Okay, water will, even though it takes a long time to heat up with that energy, it's going to hold on to it for a lot longer and it's going to stay warmer for longer. So like I said, since so much energy is required to change the temperature of the water, water heats up very slowly, and it also is going to cool down very slowly, which means that heat is often stored in large bodies of water like oceans or lakes. Go back to that summer day, let's say we're now like mid-July, if you're on a lake or near the ocean that's near land, when the sun goes down, the air cools down quite quickly, but the water actually stays warmer than the air. And this is why sometimes you will see like steam rising from a lake when it's like late at night or super, super early in the morning. It's because the water is warmer than the air and it's giving off heat into the air. Now, opposite that, during the day, when the water is cooler than the air, it's going to be absorbing heat and getting warmer. Animals, anything living in water, they have a very stable environment because it takes so much energy to raise the temperature, and it takes so much time to lose that energy to lower the temperature, that the temperature doesn't have a huge wide range like air temperature does. Air temperature varies a lot more than water environments. So plants and animals living in the water have actually very stable environments. Now, water also helps us out in the sense of evaporative cooling. What that means is that, and we've talked about this before when we talked about how a psychrometer works, when we were talking about relative humidity. When you're hot, like when you're outside playing in the summertime, let's say you're playing basketball or soccer or baseball, or you're just running around, you're outside, you're hot, you start to sweat. Why do you start to sweat? It's your body's way of cooling down your internal body temperature, okay? So you sweat. Your sweat is mostly water. There's some urea in it too, but it's mostly water. When that water evaporates off your skin, it takes heat with it and causes you to cool down. That is evaporative cooling. So that's how sweating works, because as the water evaporates off your skin, it's taking heat from the person, from you, and leaves your body cooler than it was to begin with. Now, the last thing we're going to talk about today is why ice floats, okay? Most substances, as they freeze, get more dense. So remember when we're talking about density, D equals M over V. There we go. D equals M over V, which means, so you have density is mass divided by volume, okay? So most things, when they move from being a liquid to a solid, the volume decreases, which means that the density is going to increase. So if the mass stays the same and volume goes down, density is going to go up, okay? That's what happens with most things. Water is very special because as it freezes, those hydrogen bonds that are between those water molecules actually spread out. They get longer. So when you go from liquid to solid, see how there's more space between the water molecules? There's little space here. There's a lot more space here when it goes to solid. So what's happening is that when ice freezes, when water freezes, volume increases. Because the volume increases, the density actually goes down, okay? And that's why if you have a glass of water and you have ice in that glass of water, the ice actually floats to the top because it has more volume, which means it is less dense. That actually becomes very important when we're talking about plants in water. If ice was more dense, it would sink. So you would have let's say if ice was more dense, okay? So if ice is more dense, the top of the water is gonna freeze first, and that ice would sink to the bottom. And then the next layer would freeze and it would sink to the bottom, and then the next layer would freeze and it would sink to the bottom, which would leave the entire lake frozen solid. If the entire lake is frozen solid, what happens to all of the fish and plants and other animals and things that live in this water? They would all die because there would be no liquid anymore. It would be all solid. So because ice is less dense and it stays at the top, so what you have is you just have one solid layer of ice covering the top of the water, and down here remains liquid. The top layer of ice provides an insulation to the liquid water, allowing this to stay warm, allowing this part down here to stay warm enough to sustain life throughout the course of the wintertime, okay? So what you have here is you just have this bottom down here that's covered by that ice that still has fish and plants and whatever like water animals and plants there are, that's being insulated by that ice and actually kept safe because that ice is going to stay at the top of the lake and it's not going to sink down, and it's going to cause In insulation, it's going to keep that water at a temperature when it can remain liquid.